In this lesson, we're going to be looking at filling in the unit circle. As a reminder, what a unit circle is from some previous notes, we'd previously worked with the unit circle, and as a reminder, a unit circle just means that the radius has a length of 1 unit. In addition, we're also going to be putting on our unit circle the angles determined by pi/6 increments and the angles determined by pi/4 increments. When I return to the unit circle worksheet that we're going to fill in, you're going to see that these two unit circles, the pi/6 and pi/4 circles, have been superimposed together, put onto this unit circle together. So we're not only going to be looking at increments of pi/6, but also pi/4, but instead of two separate circles, we're going to be putting those on one circle. All right, we're asked to fill in the unit circle. So what do we know so far? Well, we do know the angle measures in both radians and degrees. So let's go ahead and take a moment to fill in the blanks that represent those angle measures. So I might start over here on the positive x-axis. Okay, so what's the angle measure here when I'm not even lifting up my initial ray? Well, it's 0 degrees and it's 0 radians. We'll fill in these ordered pairs later. All right, let's jump back up to here. Well, if you need to have your other notes in front of you, okay, what that's suggesting is that I want to look at the pi/6 circle. So right here, this is going to be 30 degrees, but we also know 30 degrees is equivalent to pi/6. So the blank that has a degree symbol on it, of course, is where you're going to put the degree measure. The other blank here within the unit circle is where you're going to put the equivalent radian measure. All right, so let's just go ahead and take a moment. And what I'm going to do just methodically is I think I'll just go around and I'll fill in all increments, multiples of 30 degrees. So right here, we can see that in between 30 degrees and 60 degrees, this is our 45-degree angle. So I'll come back and pick that up later. So I'm just going to do 30, 60 degrees, which is pi/3. So again, have your other notes in front of you, but try and self-assess and see if you can remember that 60 degrees is pi/3. And kind of a good way to remember it is that if you're going to transfer from degrees to radians, remember pi could be equivalent to 180 degrees, so 180 degrees divided by 3 would give us 60. So 30, 60, this is 90 degrees, pi/2. Okay, next angle measure here is 120 degrees because that's 30 degrees more. And I can see this as 1 pi/6, 2 pi/6, 3 pi/6. This is going to be 4 pi/6, but we reduce that 4/6 to 2/3. So see how many of these that you can fill in by going around the circle. Oh, that's not 150 because that's going to be a pi/4 or a 45-degree increment. So I've got to skip this middle one here, add another 30, and I get 150 degrees. This is 180 degrees. I'm going to do the degrees first and then come back and manage the radian measures. Add 30, skip this one, add 30, get 240. This is 270 degrees. This is 300 degrees. Skip this angle and add another 30 and we get 330 degrees, which brings us up here. So 360 degrees is coterminal with 0 degrees. Okay, remember this is reserved for the radian measure. Let me go back and pick up the other degree measures that are multiples of 45. So 0, this is going to be 45 degrees. It's halfway in between quadrant 1. This is 90 degrees, add another 45. That's going to be 135 degrees. Add another 45, that's 180. Add 45 to 180, this is 225 degrees. We're at 270. The other one midway through quadrant 4, add 45 to 270, so this is 315 degrees. So doing a quick scan, I can see that I've filled in all my degree measures. So now let's go back and fill in the radian measures in terms of pi. All right, so we know that this is 1 pi/6. Let's skip this angle. This is 2 pi/6, 3 pi/6, 4 pi/6. Skip this angle, 5 pi/6. It gets a little bit confusing and crowded because we do have both increments of pi/6 and pi/4. I get it. So 5 pi/6, this would be 6 pi/6, which is simply pi. Then 7 pi/6, skip this angle, 8 pi/6, which is 4 pi/3. And always remember that you can kind of self-assess, but go back and double check your work with this pi over 6 circle that we filled in before. 4 pi over 3 was what, 8 pi over 6. So this is 9 pi over 6. But when reduced, we know that's 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 10 pi over 6, which this is 11 pi over 6. All right. And then we still have yet to fill in the increments of pi over 4. Pi over 4. So this is 1 pi over 4 here. This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. And this would be 8 pi over 4, which reduces to 2 pi. All right, so I'm going to go ahead and share with you, I kind of highlighted just for myself, I highlighted in pink the pi over 6 increments, and I highlighted in yellow the pi over 4 increments. So if you wanted to do something like that too for yourself, that's just kind of a quick visual for me. If I'm looking for pi over 6 increments, I know I'm looking for pink or whatever color you choose. Okay, again, remember that the unit circle means that the radius is 1 unit in length. And here, just to remind ourselves that these are the pi over 6 and pi over 4 circles merged onto 1 unit circle. All right, you might notice also that what we have left here is to fill in some ordered pairs on the circumference of the circle of this unit circle. So let's just go ahead and tackle some of the ordered pairs that we can fill in. Well, I see that right here for this ordered pair in the coordinate plane, then I'm over 1 and up 0. When I look at this ordered pair that represents this point right here, I don't know what the values of the x and y coordinates are. I don't know how far over I went and how far up I went to get to that ordered pair. I do know I'm not going over as far as 1, so I know this value will be less than 1. And it looks like I'm going up less than I am going over. So this number right here, this y coordinate, is going to even be smaller than this x coordinate. But I don't know them. I can't even guess them. That's going to be our objective here in a minute, is to figure out exact values of this ordered pair right here. And we'll develop that in a minute. So let's go on and go, well, can we figure out what this ordered pair is, this x and y coordinate? No, the only thing I know is that the radius length is 1. All I know is how long each of these radii are, and they're 1. So I can't figure out, to get to that point, how far over and how far up I go. That's going to be part of our later lesson. I don't know how to figure out these values yet, but using special right triangles here in a minute, we're going to be able to fill these in. I can figure out what this ordered pair is, because from the origin, I'm not going over any. But I am going up a distance of 1 because that's the length of the radius. 0, 1, and again, we can't fill these in, but I can fill in this ordered pair of -1, 0, because I'm going a distance of -1, or going a distance of 1 to the left and not going up any. And the only other ordered pair that I can fill in is this one down here on the negative y-axis. So this is going to be 0, -1. So our task next is to figure out what are these coordinates right here. And we're going to use our special right triangles from our previous lesson to help us with that. So I'm going to set this aside because this is going to be my finished product here in a minute. So I'm going to go back to my other unit circle right here. And if you wanted to have 2 yourself, that's fine. Or if you wanted to work on just your 1 unit circle, that's fine as well. All right, so again, like I know, this is 1, 0, etc. Here, I'll go ahead and get these filled in, and 0, -1. All right, what are the values here for these coordinates? Well, we're going to use the special right triangles. So what I want to know is, what's the location of that point right there? Well, what I do know is that this distance right here is 1, because that's the radius of that circle. So that has a distance of 1. Well, let's say that I go to this point right here and I drop an altitude. An altitude is what you're going to get when you drop down and you form a right angle. So let's drop down that altitude to the positive x-axis. Notice that right now I have got this right triangle that's created from right here, which is not quite a distance of 1, up to that point right there. And then the hypotenuse of that right triangle is actually the radius of the circle, the unit circle, and it has a length of 1, which I don't want 1. I want the length of this leg and this leg, because this leg length right here represents our horizontal distance, which is the x-coordinate, and the length of this leg represents our vertical distance, which gives us the y-coordinate. All right, well, special right triangles. This is 90. Okay, what does this angle measure here? Well, we know this angle measure here is 30. So in that case, this angle measure is 60 degrees. Or if you want to think of this as pi over 6, that's fine, but I'm just more comfortable with the special right triangles being given in degrees. So if this is 30 degrees, this leg length right here is half the hypotenuse, so I know half of 1 is a half. Once I get this leg length right here, I can multiply by square root of 3 to get the leg length of, right here, of this, the leg length of this side of the triangle. So 1/2 times square root of 3 is simply square root of 3 over 2. Is that going to help us develop these ordered pairs? Yes. So what goes here? Well, that's the x-coordinate. The x-coordinate is the horizontal distance, which is square root of 3 over 2. Okay. And then the vertical distance is going to be this leg length, which is the y-coordinate, which is a half. So let's just double check these values. I know that both of these numbers right here should be less than 1, because the greatest distance in a right triangle would be the hypotenuse. Square root of 3 divided by 2 is going to give us about 0.8, which is certainly less than going all the way over to 1. And then 1/2, so this vertical distance must be half of that whole radius right there. So those numbers do make sense to me, and they're exact. All right, so let's skip this angle right here, this 45-degree angle. Let's just go up to now this ordered pair right here, where this point intercepts the arc length. So let's create a new triangle. So let's kind of ignore this triangle if we can. Let's go to this point, and let's drop down in altitude. So now we have another right triangle. Let me put it in a different color so it kind of maybe stands out at us. Do this. Okay, so let's look at this triangle. Okay, well, what do we know? Well, I do know that this angle measure right here, okay, is going to be 60 degrees. Well, if this is 90 and this is 60, then this little angle in here has got to be 30. So we still have a special right triangle. So what do we know about this special right triangle? Well, again, we know the radius length is 1, but we need to get the values of x and y to populate this ordered pair here. Okay, well, if this is 1, then this is 30 degrees, then this leg length right here has to be a half. So now the distance from the origin over here that lines up underneath this point is a half. That's the x-coordinate. It's a half. Well, if this leg length on the pink triangle is a half, then across from the 60-degree angle, this leg length has to be square root of 3 over 2, or a half times square root of 3. So this vertical distance is square root of 3 over 2, so we're going to put square root of 3 over 2 here. Notice the relationship between these two ordered pairs. This ordered pair starts out square root of 3 over 2, comma half, but then all we have to do is, if we memorize this ordered pair at 30 degrees, is we could just switch the x and y and put a half first, square root of 3 over 2 second. Let's use symmetry to help us go around the unit circle. Remember, when we're in quadrant 1, I don't really like this, so I'm just going to say when I'm in quadrant 1, both x and y are positive. But when I'm in quadrant 2, the x is negative and the y is still positive. So the x's are opposite, but the y's are the same. And again, when you're down in quadrant 3, negative x, negative y. Quadrant 4, positive x, negative y. All right, so let's use symmetry, our knowledge of symmetry, to help us populate this ordered pair without actually having to do another special right triangle over in quadrant 2. Well, notice that the x-coordinates should be opposite, so this x-coordinate should be negative 1/2, but I'm up at the same height, so this should be square root of 3 over 2. All right, now let's drop down and see if we can populate this ordered pair. Well, these 2 points have symmetry with the y-axis, so their x's are opposite, but their y's are the same. So this should be negative square root of 3 over 2, and this should be positive 1/2. We could continue and work our way down into quadrant 3 and 4 by now thinking about symmetry with regard to the x-axis. For example, these two ordered pairs right here, okay, they have the same x, but their y values are opposite. So I'm at the same x, but my y, the same x, they're both negative, but the y coordinates are the opposites because now I'm going down instead of going up. So this would be negative 1/2. Do these two negative values correspond with what we know about points in quadrant 3? Yeah, they should both be negative. So based on symmetry and what we've seen so far with special right triangles, you should be able to populate this ordered pair, and that ordered pair right there. All right, let's go back and let's look at our other ordered pairs that we still need to fill in. All right, so now I'm in a different color, I'm going to talk about this triangle that's formed by dropping this altitude. So we have this right triangle, this is 90 degrees. Well, what do we know about this angle in this orange triangle? Well, it's actually half of quadrant 1, so that's going to be 45 degrees here. So now we have a 45 right triangle. We know the relationship that exists. Well, which side length do I know? Well, I know the radius is 1. If I know the radius, then what do I do to go back to the side lengths? Well, we divide by the square root of 2. In a 45 right, to go from the hypotenuse to the side lengths, we divide by square root of 2. Not 3, but square root of 2. So this leg length is 1 over the square root of 2. We like to rationalize this, so don't forget we're going to multiply by square root of 2 over square root of 2. So what we end up with is square root of 2 over square root of 4, which is just simply 2. So this leg length in the orange triangle is square root of 2 over 2. So that's going to be the height, so that'd be the y coordinate. Okay, and now how long? What's the vertical distance? Well, it's going to be the same, so this ordered pair should have the exact same coordinates. All right, let's see if we can use symmetry to help us figure out what goes here in this circle. Well, same y's, but opposite x's. So the x is negative, but the y's are the same. And then from there, you should be able to fill in the missing coordinates down here in quadrant 3 and in coordinate 4. So at this point, we should have everything filled in that had a blank that needed to be filled in. Okay, we should have all the degree measures in increments of 30 or 45 degrees. We should have all the the angle measures and also radians in terms of pi, and multiples of pi over 6 and multiples of pi over 4. And we should have every single ordered pair filled in around our unit circle. All right, so this is my finished product, but it's obviously not finished. So I'm going to try and self-assess and see if I can remember how to fill these in. And that's what I would suggest you do. At one point, we're going to have to memorize these. And then on future tests, after we have a test or two where we don't use our unit circle and we've memorized it and we have the values, then we are going to be able to use the unit circle later, but not in the very beginning. All right, so let me see if I can remember what ordered pair goes right here. Well, let's see, that's 30 degrees. So if I can't memorize, I could, again, build another right triangle. This is 30 degrees. This is going to be a half. So I know the vertical distance is a half, and this is square root of 3 over 2. So once I get that there, I can switch the ordered pair. And then when I move into quadrant 2, I know that the x's are opposite, but the y's are the same. So it would be a quick thing for me to fill in. Okay, these 2 points are here have opposite x's, but the same y's. Okay, these 2 points right here have the same x. They're both negative, opposite y, so those are both negative coordinates. And then I can just switch these 2 right here and get negative 1/2, negative square root of 3 over 2. When I move into quadrant 4, I know I need a positive x, but still a negative y, etc. So if you can print off a couple of unit circles, that would be a good thing for you to do, and just see how fast you can go in labeling all the degree measures, the radian measures, and also the ordered pairs. Find yourself a system that would make you efficient in memorizing all of those. Okay, and then likewise, the last thing for me to do to have my finished product is to fill in the ordered pairs at all the increments of pi over 4 that aren't on one of the axes. All right, we'll pick up in another video and do some more work with the unit circle.